Hi, my name is Daniela Baccas and I live in Rio de Janeiro city, capital of the state of Rio de Janeiro in Brazil, South America. Over the next few minutes, I hope to introduce you to the unique geography of Rio de Janeiro and the special challenges this tropical metropolis faces when considering the impacts of climate change and the current projections for the future. According to the Brazilian Institute of Geography and Statistics, IBGE, the city has a population estimated at 6.7 million people, the second most populated city in the country. It's located in the southeast coast of Brazil and its territory corresponds to 1,200 square kilometers. Its landscape, full of mountains covered by tropical Atlantic forest, surrounded by beaches, bays, and lagoons, has made it renowned worldwide. European-style buildings were constructed in the city center by the Portuguese colonizers, while the urbanization process proceeded erratically. Social and economic inequalities forced people to live in marginalized spaces lacking public facilities. This was the origin of the slums on the steep slopes, the favelas, made of precarious construction materials and where approximately 20% of the population of Rio de Janeiro city live, adjacent to wealth neighborhoods. Yet another part of the working class was pushed to the outskirts within the expansion of transportation network to the suburbs. Rural exodus and economic growth made the city into a major metropolis. Nowadays, trade and service represent more than 80% of the city gross value added, followed by industries at about 15%. The contribution of the agriculture sector is no longer significant. Expansion of the city claimed mangrove areas among lagoons in the sea, where new skyscrapers and infrastructure have been constructed. The metropolitan region of Rio encompasses 19 cities and accounts for 12 million inhabitants, interconnected by trains, roads, and ferry boats. Economically, it's the second most important in the country, after São Paulo. Rio has a tropical climate with no substantial transition among seasons, especially in terms of temperature. The annual average is around 25 degrees Celsius, but precipitation is more concentrated in summer months, from December to March. This graphic demonstrates the average monthly temperature available in the official records. In the last 5 years, with full available data, 2012 to 2016, we see there has been an elevation in temperatures both in summer and the winter months, with the annual average growing more than 1 degree Celsius in comparison with the baseline. The same trend applies for minimum and maximum temperatures. There has also been a remarkable increase in this 5-year period from 2012, and the outcomes are that all the months are getting warmer, including winter months, June to August. With regards to precipitation, the two 30-year period references taken into account indicate no substantial variation. The average of the last 10 years with data accessible demonstrates sharp decreases in rainfall patterns for some months of the year, such as February and August, and on the other hand, a rise in January, March, November, and December. The city has suffered several cases of extreme weather events. Recalling more recent episodes, there were heavy rains in April 2010 and February and April of this year, all of them followed by landslides, tree falling, and floods. They also caused displacement and disturbances in transportation system, businesses, and energy. In 2010, the city registered more than 60 deaths, and in the last storms, which occurred in February and April this year, there were more than 15 deaths. The intensity was so high that the precipitation level in just one day in April was reported as the worst in the last 22 years in the city. The water flow damaged houses and urban roads. Some remain closed until today. The impacts were exacerbating for commuters, whereby the city was paralyzed by heavy traffic, boosting the risk of drownings and injuries. Part of the bicycle path in the coastline, aligned with the avenue, has been dismantled. Another example of climate impact are the urban heat waves that have become an issue. Records of hundreds of deaths beyond the typical findings have been registered between 2 and 9 February 2010 in the metropolitan region of Rio, an extremely dry month associated with escalating temperatures, which resulted in a great impact for human health, mostly upon the elderly. The education strategy elaborated in 2016 for the city used projections made by the National Institute for Space Research based on an original climate model. The simulation is derived from IPCC RCP 8.5 scenario. It indicates temperature increase up to 4 degrees Celsius for 2011 to 2040 period and up to 8 degrees until 2100 over the baseline period. Some of the consequences are noted in the prediction for 2040, such as warming overall temperatures with higher minimum and maximum figures and recurring days of maximum temperature above 25 degrees Celsius and minimum temperatures higher than 20 degrees. Drier days are predicted to become more frequent as well as heat waves. Until 2100, rainfall decreases 6 mm per day below the regular level. Another study led by André Lira and other authors also assesses projections based on IPCC scenarios RCP 4.5 and RCP 8.5 for the metropolitan region of Rio de Janeiro. As the weather gets warmer, drier conditions are accentuated. The graphic shows the pronounced reduction in precipitation pattern in summer months and a shortened winter season. Referencing the historical baseline, it reaches about 50% of rainfall reductions in accordance with RCP 8.5, especially in summer months. Even in the RCP 4.5 scenario and considering the first time slice, the model indicates alarming drops in rainfall and a consistent trend of rising temperatures. Different from this adaptation strategy that doesn't adequately demonstrate the extreme weather events, this simulation concludes that there will be an increased strong rains occasioned by the frequency of events with more volume per day, especially under RCP 8.5 scenario. Regional models are compatible with the IPCC assessment of climate change effects in the southeastern South America, where Rio is encountered. In summary, the fifth report points out an overall increase of temperatures expected, reaching more than 2 degrees Celsius in the worst RCP scenario projected by 2050. Moreover, the IPCC study highlights a perspective of increasing precipitation index for eastern South America, and in this case, it differs from the local projections previously commented for Rio. Nonetheless, it indicates more extreme rainfall occurrences, expecting more hazardous effects for this vulnerable region. The simulations, though, vary on resolutions and uncertainties are an issue, especially in rainfall figures, as stated in the IPCC report and as we could observe. In alignment with the projections previously shown and as identified in the city strategy, Rio de Janeiro will face an uncomfortable warming period in the future, with most of the impacts on urbanization and housing, urban mobility, infrastructure, and health. As a city located on the Atlantic coast of Brazil, it becomes more vulnerable within a future in which the IPCC projects a substantial sea level rise. Coastal constructions and daily activities such as sports and tourism surrounding bays and beaches might be negatively affected within the elevation of the sea level and heavy storm surges, which can also cause runoffs to avenues and potential disruption of airports and hazards to the port region. Structures may be spoiled by corrosion and drains can suffer sand deposits, causing floods. Transportation and navigation, including those to and from neighboring cities, may be interrupted. As a consequence, transborder impacts will appear since there are several main roads, cruises, cargo shipping, and flights arriving in and departing from Rio. At the same time, the city purchases agricultural goods, industrialized devices, and energy, among other items, from other regions of the state and from other places in Brazil that are about to be impacted by drought, potentially affecting the city's supplies. Additionally, the impacts of extreme rainfalls are more intense considering Rio's geological features, which are vulnerable to landslides worsened by irregular occupation of forest slopes and by deforestation, which shifts the soil resilience. Urban mobility might be impaired and the deposit of sediments can overload the drainage systems, causing floods and all its damaging effects. Waterborne and vector-borne diseases are also expected since some vectors rely on water and hot weather for reproduction, such as the Aedes aegypti, which proliferates yellow fever and dengue. Urban areas are more susceptible to form heat islands and increasing health problems such as respiratory disease, mainly affecting elderly and children. Biodiversity losses as a result of rising sea levels, landslides, and land degradation and deforestation, including from other regions of Brazil, such as the Amazon, might even worsen impacts and vulnerability since they destabilize climate standards and water supplies. Financial losses derived from non-resilient infrastructure and higher pressures on health systems can impose a burden on public budgets as well as interrupting business and education due to the lack of mobility, water scarcity, energy disruptions, and disease. The impacts mentioned, from temperature rise and rainfall variability with extreme events projected, are expected disproportionately, affecting more vulnerable people given the social inequalities and poor housing conditions in many parts of the city. Therefore, these projections and the evaluation of impacts are paramount to preparing and adapting Rio de Janeiro for the forthcoming climate.